We are going to see the next problem based on velocity. A tightly stretched string between the fixed endpoints x equal to 0, endpoints x equal to 0 and x equal to L is initially at rest in its equilibrium position. If each of its points is given by the velocity, it is given lambda x into L minus x. So, here velocity is given. So, initial displacement is not given, that is why you have to consider that value is 0. So, first as usual you have to consider the one dimensional wave equation. So, one dimensional wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. Next you have to consider the possible solution, the correct solution of one dimensional wave equation is y of x comma t equal to a cos px plus b sin px into c cos pat plus d sin pat. This is our correct solution of one dimensional wave equation. So, you have to take this one as equation number 1. Next you have to consider the boundary conditions. Here the boundary conditions are, first one you have to fix the string initially in rest, that is why you have to consider y of 0 comma t value is 0. Second one y of L comma t, because you have to fix the string at x equal to 0 and x equal to L. Initially it is in rest, that is why you have to consider y of 0 comma t value is 0 and y of L comma t value is 0. Next one, here initial velocity is given. So, you have to consider initial displacement value is 0. So, y of 0 comma value is x comma 0 value is 0. Initial displacement at time t value is 0. Fourth boundary condition is your function, that is velocity is mentioned by dou y by dou t at x comma 0 at time t equal to 0, the function is actually lambda x into L minus x. So, it is lambda into Lx minus x square. Now, you have to substitute your boundary conditions one by one in equation 1. So, suppose if you substituting first boundary condition, substitute first boundary condition in equation 1. Your first boundary condition is y of 0 comma t. So, y of 0 comma t value is, y of 0 comma t means x in the place substitute 0. So, if you are taking x in the place 0, a into cos 0 plus b into sin 0 into t term you have to consider as it is. So, c cos bat plus d sin pat. By the boundary condition it is 0. So, y of 0 comma t value is 0. A cos 0 value is 1. Cos 0 value is 1 means a into 1 become a, sin 0 value is 0 into c cos pat plus d sin pat. So, a into cos pat plus d sin pat value is 0 means we have two possibility value is 0, either a value is 0 or the whole expression becomes 0. C into cos pat plus d into sin pat value is not equal to 0, because if you substituting it as 0, totally your correct solution becomes 0. That is why C cos pat plus d sin pat value is not equal to 0, since your y of x comma t tends to 0. So, y of x comma t equal to 0, that is why the whole expression is not equal to 0. Therefore, only one possibility is a value is 0. So, substitute a value is 0 in your correct solution. So, substitute a value in correct solution 1. So, if you substituting a value 0 in our correct solution 1, your correct solution become y of x comma t equal to a into. So, a value 0, that's why you have to take b sin px into c cos pat plus d sin pat. So, now this is our correct solution, that is why you have to consider in equation 2. You have to consider the equation as equation number 2. Next, you have to substitute second boundary condition in equation 2. Second boundary condition is y of L comma t. X in the place substitute L. X in the place if you substituting L, it become b sin PL into c cos PAT plus d sin PAT. So, x in the place if you substituting L, it becomes sin PL into c cos PAT plus d sin PAT. Here we have by the boundary condition your y of L comma t value is 0. So, 0 equal to b sin PL into c cos PAT plus d sin PAT. Here we have three possibility, either b equal to 0 or sin PL equal to 0 or c cos PAT plus the d sin PAT value is 0. Already we have seen your c cos PAT plus d sin PAT value is not equal to 0 because of your y of x comma t tends to 0. Similarly, your b also not equal to 0 because b is in multiplication. So, your b value is not equal to 0 since y of x comma t equal to 0. Therefore, only one possibility is your sin px value is 0. Therefore, sin px value is 0. Sin PL value is 0, instead of your 0, we can take sin n pi because sin n pi value is always 0. So, sin PL equal to sin n pi, PL value is n pi. So, P value is n pi by L. Now, substitute your P value in the previous correct solution. Substitute P in the correct solution 2. Your y of x comma t equal to b sin n pi x by L into c cos n pi a t by L plus d sin n pi a t by L. So, if you are substituting p value in the previous correct solution, you will get y of x comma t equal to this one. Now, you have to take this one as equation number 3. This is our correct solution. Now, substitute your third boundary condition. Substitute our third boundary condition in the previous correct solution. Substitute third boundary condition in equation 3. Third boundary condition is y of x comma 0. Y of x comma 0 means t in the place substitute 0. T in the place if you are taking 0, cos 0 value is 1, sin 0 value is 0. That is why your y of x comma 0 equal to b sin n pi x by L into c cos 0 value is 1. That is why c. By the boundary condition, your y of x comma 0 value is 0. So, 0 equal to b sin n pi x by L into c. So, here we have three possibilities. So here b value is 0 or sin n pi x by L is 0 or c value is 0. Already b into sin n pi x by L is, it is in multiplication. So your b sin n pi x by L value is not equal to 0. So b value is not equal to 0 and sin n pi x by L value is not equal to 0 because of your y of x comma t tends to 0. So your correct solution become trivial solution, therefore b not equal to 0 and sin n pi x by L is not equal to 0. So only one possibility is c should be 0. Substitute c value in the previous correct solution in equation number 3. So y of x comma t equal to b sin n pi x by L into d sin n pi a t by L. The first term is 0 because of c value is 0. Next one you have to consider this before substituting the last boundary condition. Last boundary condition is dou by dou t. You have to differentiating partially with respect to t in the most general solution. So you have to consider the most general solution. First you have to take your constant value as bd value as bn. So your y of x comma t equal to bn into sin n pi x by L into sin n pi a t by L. Therefore, we can consider the most general solution as y of x comma t equal to summation n equal to 1 to infinity bn sin n pi x by L into sin n pi a t by L. Now this is our correct solution. So you have to consider this one as equation number 4. Next you have to differentiating partially with respect to t in this most general solution. So differentiating partially with respect to t in this equation, it become differentiating partially with respect to t in equation 4, it become dou y by dou t at x comma t equal to summation n equal to 1 to infinity bn sin n pi x by L into differentiation of sin n pi a t by L is cos n pi a t by L into t coefficient you will get in the multiplication. So cos n pi a t by L into n pi a by L. Now substitute your last boundary condition in the above equation. Last boundary condition is dou y by dou t at x comma 0. At x comma 0 means t in the place substitute 0. T in the place if you are taking 0, summation n equal to 1 to infinity bn sin n pi x by L into cos n pi a t by L become t in the place if you are taking 0, cos 0 value is 1. So into n pi a by L. This is equal to f of x. Your f of x value is lambda into Lx minus x square. Already we have seen in the type 1 problem, lambda into Lx minus x square is the function. We have to expand the function by using sine series, half range sine series, because you have to equal bn into sin n pi x by L equal to this function. That's why you have to expand your f of x by using half range sine series, that is f of x equal to summation n equal to 1 to infinity bn sin n pi x by L. If you equating these two, you will get your capital Bn into n pi a by L equal to small bn value. So, you have to find what is the value of Bn. We can find what is capital Bn by using your small bn, Bn into L divided by Bn into L divided by n pi a. So, next you have to find what is your Bn value, small bn value by using half range sine series. Where Bn equal to 2 divided by L integral 0 to L f of x into sin n pi x by L into dx. So, your function is lambda into, so you can take lambda as outside divided by L integral 0 to L, your f of x value is Lx minus x square into sin n pi x by L into dx. So, here also you have to integrate this function by using Bernoulli's formula, because we have two functions in x. So, you take u equal to Lx minus x square and remaining value is dv, dv value is sin n pi x by L into dx. So, first you have to integrate this function. If integrating this function, we will get sin integration is minus cos. So, minus cos n pi x by L divided by n pi by L. Next one, you have to differentiating this function. If you differentiating Lx minus x square, it become L minus 2x. Integration of v is v1, v1 value is minus integration of cos is sin. So, sin n pi x by L divided by n square pi square by L square, because already we have n pi by L. So, it become n square by pi square by L square. Next one, differentiation of u dash is double dash. L minus 2x become minus 2, L becomes 0, minus 2. Integration of v1 value is v2. Integral of sin is minus cos, already we have minus sign, that is why it become plus cos n pi x by L divided by n cube pi cube divided by L cube. You have to stop up to this one, because if you are differentiating double dash, it becomes 0, because already we have minus 2, the constant term. Now, you have to substitute in Bernoulli's, therefore, Bn value is 2 lambda by L into Lx minus x square. You have to consider every function within the bracket, minus cos n pi x by L divided by n pi by L. In the formula, we have minus symbol, L minus 2x into minus sin n pi x by L divided by n square pi square by L square plus minus 2 into cos n pi x by L divided by n cube pi cube by L cube. Your limit is 0 to L. If you substituting the upper limit in the first function, Lx minus x square, L into L square minus L square becomes 0. If you substituting lower limit 0, 0 minus 0 becomes 0. So, totally first function becomes 0. If you considering the next function, L minus 2L become minus L, but in the sign term, if you substituting x in the place L, L get cancelled, sin n pi value is 0. If you substituting the lower limit 0, sin 0 value is 0. So, totally second term also 0. So, you have to consider only the last term. So, Bn value is 2 lambda by L into minus 2 L cube divided by n cube pi cube into, if you substituting x in the place L, L get cancelled, it become cos n pi. Cos n pi value is minus 1 the whole power n. So, minus 1 the whole power n minus cos 0 value is 1. It become minus 4 lambda, L and L cube get cancelled, L square divided by n cube pi cube into minus 1 the whole power n minus 1. If you multiplying by minus, it become 4 lambda L square by n cube pi cube into 1 minus minus 1 the whole power n. This is our Bn value. So, if you considering n values any even value, minus 1 the whole power square means it become minus 1 the whole square become plus 1, 1 minus 1 become 0. That is why you have to consider two cases when n is odd and when n is even. If you substituting n in the place any odd value, suppose if you considering n equal to 1, 1 minus of minus 1 become 2. So, it become 8 lambda L square by n cube pi cube. When n is even, if you considering any even value, your minus 1 the whole square become 0. That is why multiplication of 0 is 0. So, now consider what is your capital Bn. Already your Bn value was Pn into L divided by n pi a. Therefore, your capital Bn become 8 lambda L square into L become L cube, n pi a you have, that is why it become n power 4 pi power 4 a when n is odd. It is 0 when n is even. Finally, you have to substitute your Bn value in the most general solution. So, your most general solution become substitute Bn in most general solution, your y of x comma t become summation. When n is odd, we have the value, that is why you have to consider n equal to 1, 3, 5 etc. up to infinity 8 lambda L cube divided by n power 4 pi power 4 a into sin n pi x by L into sin n pi a t by L. So, this is our initial, this is our displacement of the function y of x comma t. Thank you, students.